Okay, cool. I think I should be back now. Hopefully the encoding is a bit better. And yeah, I'm using hardware encoding now. Should probably speed things up a bit. Hopefully. Let's see. At least YouTube tells me that connection is very, very good now. Okay. It's kind of weird though that it wasn't before. Okay, then let's try to continue here. I think now you should even see my editor. Very nice. So where even were we? Yeah, we're still trying to fix that one bug, right? Yep. Okay. Base blocks must have a terminator. So, why does it not work? Was something a failed while formatting, right? Right. So maybe. Maybe we should check the display implementation. So. Okay, so we panic after a few steps. Like, I think it was 3, 4. Okay, so we panic after 4. 1, 2, 3. Okay, so now it's gonna be the basic block that we panic at. But why? Because we do not have a terminator. So we do not have a terminator, but the basic block still exists though. Well, that makes no sense. That definitely makes no sense. I mean, what? Why? Okay, so let's just take a look if we ever remove the terminator somewhere. So where's the terminator actually modified? So that should be, yeah, should be when we initialize the terminator. It should be fine as well. And that should be fine as well. I don't see any place where we actually remove terminator. So if we remove the basic block, we take the basic block out of the option, right? Okay. Okay, let's take a look at the basic block again. So somewhere in here, around here. Let's do that. 1, 2, 3. Now it should panic because basic block does not have a terminator. But instructions should have none. Okay, wait. It does not have a terminator anymore and has no instructions. Wait, its ID is 1. So it's this one, but it doesn't have an instruction usually. So I guess that indicates that that the remove basic block function is called, method is called, but the basic block is still around somehow. Or how? Let's take a look at the stack trace again. Where is it called from? Where is format called from? Oh. Okay, so it's called from here. And it panics here. Like 20, which is mod 2, which is the one that we parse. Oh. That makes sense. Shit. Okay. So, what's happening is we have this pass here called front bridge, which basically creates like the AR representation from the parse structures. And because we allow like skipping these IDs, so for example, this would be valid. See, we don't define BB1 anywhere, but we can still define BB2. And to achieve this, we create empty blocks, I think. Yeah, right. Which is dumb, I guess. Should be a much simpler way to do this. And I think actually there is. I guess we could create a new basic block at a specific position. And this method should not be visible in our crate. And what we can do is this, where we say the ID is in the base block ID. I think we don't even need to return something here. And I guess we would need something like this as well. So next ID, we don't need that, just that. And then we can say, okay, insert with a key. I don't think we can though. Insert. Okay. New empty block. So we just insert none then, I guess. Right. That would work. So we just say basic block ID, and the only thing we do is push a new value, but it's empty. So it's just none. And now what we can do in the front bridge is we can create basic block. Now, like for every basic block, that is not defined yet, we would need to insert an empty basic block, but that will also lead to problems, because I think this ensure VBA exists method, if we call that, we can be sure that the basic block exists and is not none in the arena. But now it can be none. So I think we might. What do we have to do? Right. So can either say empty block or new basic block. So basically, when we want to ensure that a basic block exists with a given ID, we need to either push new basic blocks, or if the basic block ID is greater than the length of the basic block arena, we need to replace, if it's none, we need to replace the basic block at this position with a new basic block, I think. Right? That should make sense. So we can say ensure exists, and then ID, basic block ID, don't need to return anything. And then we can probably match self basic blocks as huge, I think, like this. So if we have basic block already, then it doesn't matter. Okay, maybe getter insert with. Yeah, that makes more sense. Seems more like what we need. So if we do not have a basic block, so if the value at its place is none, then this method will be called. And there we need this, I think. Something like it at least. We don't need that. We just need this ID. And we need to add a node. What does that even do? Wait, it adds a node and does nothing with it? Oh no. That's not true. Yeah, I remember. Oh, it's too long ago. No, I think the mapping between the node indices and the basic block indices is just one-to-one. Basically like this. So yeah, every time we create a basic block, we also have to create a node. That means even when we create an empty block, we still need to add a node. And that means we can just return this here, I think. That should actually be fine. Is it fine? I think so. Yep. Okay. That could be a problem if the entry block is left out. Okay, that's something that we have to validate as well, I think. Because right now we can just leave the basic block, the entry basic block out. So we can just start with VP1 here, which is bad though. I mean, we don't want that. That's something that we are assuming right now. I can just, let me add that to the checklist for the verifier. Check entry basic block exists. Okay, cool. And if you want to, there's the issue that we're working on right now. You can take a look. Post it in the chat. Or you can also look in the description, I think. So I think that should work. Now we just need to use the new method somewhere in the front bridge, right? Okay. So here you can say just empty. What did I call it? All right, it's not even, the method is not even defined in the builder. Maybe create empty basic block. I think should work. New empty block, blah blah blah. So we just create an empty block, and then ensure that it exists. I think that makes sense. Help. What the? Okay. Ensure exists. Ensure exists. It needs an ID though. Basic block ID. Blah 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 blah. Pass it here. This does not need to return anything. Like that. Okay. Run test. Please work. It's failing. Oh no. Okay, that's bad. Entry block has not been created. Oh, okay. That makes sense, I think. So what's happening now is that when parsing this, when basically trying to create the internal structure from the parse grammar, we create empty blocks for each of those and then initialize them later with the ensure exists method. But what it now is never called is this block, and therefore we never set the entry block. But honestly, I think we can also just assume that the entry block always is as an x0, right? So we can just say that like this. What are you complaining about? Set entry block. Okay, entry block. Blah blah. Can type should be index 0. I guess. Right, like this. Maybe. Does it work? Should work. Bam. Okay. pray with me. Let's go see if we have any failing tests left now. No, we don't. All tests are passing. That is very good. Nice. So now we came back on actually implementing the verifier. So just grab a drink real quick. Not an actual drink. Water. Okay. Where even were we? I don't remember. Okay. Check for missing terminator. Right. Have we written a test for that? Yep. Okay, I think that should even be enough, I guess. Right, okay. Cool. What do you mean by entry block should be index 0 function use? You mean like where it's used or something else? Because just a test. See, it is. Wait, where is it? Where even is the test? Entry. Should index 0. Yeah. See, it's annotated with the test annotation, or not an annotation. Like basically, I think a macro. Yeah. So that's how it's called. If that's what you mean, I don't know. Okay, so what do we want to do next? I think we could try to either check branch arguments or do type checking. I don't know. If anybody in chat has a preference, you could say so, then we'll do that. Otherwise, I think I will go with type checking, I guess. Yeah. Yeah, the other one would be branch arguments. So, where's an example? Let's see. Yeah. So the other one would be to validate that for every branch we pass the correct arguments for the basic block, like correct types and correct amount, I think. Yeah. Okay, first one. Yeah, and we'll go with type checking. So now, what do we need to do for type checking? I think, for example, this would not be valid because we cannot add like a 32-bit integer. Okay, not okay. Maybe that's a bad example though, because we choose not to actually define, so it does not have a type. But wait, we do that. So now that's better. If we do that, that should not be valid, right? Because you cannot add a 16-bit integer to a 32-bit integer, and even this should not be valid because you should not be able to add two 16-bit integers and get a 32-bit integer as a result. I mean, not without any sorts of casts, I guess. Yeah. So let's first write a test, and then implement it. So Yes, we first need an error type, so something like missing, not missing, maybe type mismatch. And then we'll have expected with type to input that. And then actual type and the location. Okay, no copy, makes sense. Now the error message will be something like actual, expected. Just can ignore for now. Will be something like write f the message. I don't know. Expected type expected, but got actual. Maybe like that. Expected. No, that's not correct. Okay. Cool. That's the ready test. I don't yet know how generic the type matching can be. We'll see about that. For now we can just say should report type mismatch match on add instruction, I guess. So let's just copy this and say we'll have a 16-bit integer, maybe I16 constant can just be 0, and then we'll try to add 8 to v0 and then return v0. Okay, cool. Now that should be invalid because we try to add 16-bit integer to some other integer, and it should produce a 32-bit integer. So for now this test will probably fail. Yep, because we didn't even specify the correct error. Type mismatch. So what do we need here? Actual is type I16 and expected should be type A32, and the location will be 0, and the instruction ID should be 1, right? Because this is the first instruction or the second instruction, but we have 0 indexing. Right. Okay. Let's see. It should still fail. Arrow. Like this. Okay. Yeah. No reported error, but we expected one, so test fails. That's good. Let's now try to catch that error somehow. Okay, we can do that on the first pass. So I don't know if we have to even look at specific instructions here, like this, or if we could just and say like used, used, and then just check the types of every operand that was used in an instruction. I think it should be instruction specific. For example, a locker instruction. How do we do type checking there? Like, I mean, we don't really have to do any type checking here. Not sure though. Okay, let's just only look at the add instruction to make our tests happy. So it will be add instruction. It's even, yeah, add instruction. So what do we have to check? We have to check whether the type of the right hand side, the left hand side, and the type that was specified for instruction match. So the instruction type is specified like so, and I think that should take the highest precedence when type checking. So we can say that that is the expected type. And then if expected does not equal to add instruction left hand side. Wait, does type does not derive eq. Okay, what? Help. Wait, what? type. It does. That's weird. Okay. Cannot be applied to type. Not required for my to implement. Oh, right. Sure. Because that is not type. Okay. How do we even get the type from this? Be instruction left hand side. Type. We can create a new instruction to get the type. So we need to implement that on up. So self, and it will return type. So we can match self and say we either have a const val, then we can return type. Can we? I don't know. Can't just define a new function there as well. Or if we have a register, we probably need a function here as an argument. And then we can just say function cfg vreg type, or it's vreg. Correct. Very nice. Okay. Const type for self and return reference to type, and that will be match on self type. No, that's a value type. Ignore the rest and return type. Cool. Yes. Lifetime may not live long enough. Okay, that makes sense, I guess. So fine. I think we have to specify the lifetime is here. But it is returning. Oh, and self has to live for the lifetime as well, right? Yeah. So we're saying that op basically needs to live at least as long as our function, which is correct. I mean, instructions live as long as the function, and ops only occur in functions and instructions, so that should be fine. Now, tie needs function. I think, yeah, have access to that. Now, left hand side type. So if those two don't match, we will report an error. Verify error, type mismatch. Actual will be left inside type clone, expected will be expected a clone, and location will be instruction v2. Okay. Let's see what I mean. Maybe like this, because I don't want to duplicate this if. So we could create an array, and then for actual in the types expected does not equal to actual, we report an error. Cool. Now let's see if the test passes. It doesn't. Now every test fails. Wait, no. Every test fails except for that one. Okay, makes sense because we have an unimplemented. Wait, what? Not yet implemented. Okay, so we're running into that to do it. That makes sense. So, I'm wondering though if it makes sense to make that instruction specific, because the only thing we really care about for each instruction are its operands, I guess. So we can just say for actual in instruction use iter into iter map up type self function like this. Yeah, now we can just take this piece of code and move it in here. And instead of having this loop here, just remove it and bam. Voila, I think we're done here. Let's see. Okay, now we're only failing one test. Why is that? Oh, wait. Type mismatch, actual void. Use before definition. Okay, that makes sense. So the error here is that v1 is of type void. Yeah, that's because it's not actually defined, and I think that default type for a VRAC is void if it's not defined, which makes no sense actually. Maybe we should change that. I guess it's kind of confusing actually. Let's see. Instruction type. What does this do? Okay, so it just returns a type that is sent to the virtual register. But when is a new register created here? Here, new VRAC. Where is this called? Is it called somewhere in the bridge? New VRAC. Because it has to be created somewhere. Wait. That is confusing. Where are these created? So what's happening here? We're parsing this. So because we see v1 here, it's probably being created somewhere, right? But where? Are they even created anywhere? What? What the hell? Oh yeah, no, I think I know what's happening. Where? Right, okay. So, this is a primary map. And or where's our test? So we're using a primary map to store our register data or information. And now, when parsing this and creating the virtual registers, we create one here with index v0, and then create another one here with index v2 or with index 2. And because primary map is based on a vector, so its underlying data structure is a vector, it creates the default for our direct info, which then in turn internally uses void as its default type. Yeah, that is bad, honestly. I think we might have to change this to be maybe an option, because I mean it's possible for this to not exist, and honestly it doesn't even implement default though. What? I'm genuinely confused as to how this happens, how it's happening. Yeah. No, I think I just talk bullshit. I think you cannot create a primary map. Does not require you to implement default for the type that you use it with. So that can't be the reason. We can just, where's type defined? No, type should be it. No, that's wrong. Maybe here. Nope. That one? Yeah, okay. So where is void used? It's used here. Hey. There we go. Okay, that makes sense. So that's where we actually said void. I don't like that, honestly. I don't. Let's change that. Let's use option here. Just say, okay, this can exist No. It is possible that it does not exist. And now what we can do here then is just push none here, I guess. Can we do that? I guess we can. Like this, empty VRAC. Need to borrow self-mutably here. And just push none. Some empty VRAC, not used anywhere, makes sense. And what we can do here is just new empty VRAC. What? Where did I define that method? What? Where is it defined? On the CFD, what? Why no access? Hello? VRAC? Empty VRAC. Oh, makes sense. Now, what we can do here is you can just say VRAC scat or insert with this. Okay. Then we return data, tie and defined in this the current basic block. Cool. Like this. And then this maybe. Now we could either return option here, or we could panic. I think we should. I think we should panic. So it says ref and then spec VRAC does not exist. Like that. Let's just try and run this. Yeah, okay, at least we get another arrow now. So we're now running into this panic, which makes sense. Because we now need to directly access the underlying data structure where the VRAC info is stored. Not do that. Okay, that's bad though. That's bad though. Shit. Okay. We just have to cannot use this method anymore because it internally uses this method, which uses this method, which panics. And yeah. So what we can do is just match the operand here. If it's const, we can just return the type of the const. If it's a VRAC, we will need to do a little more action here. And I think we even need to the flat map here. Make this sum. And then just say self function cfg VRACs. Index this with VRAC. And then say map VRAC type as ref. Very well. expected, but font type y. Okay, it's private. Screw you. Okay. Let's run the test now. Cool. Works. Very good. Okay. Now we have implemented type checking. I don't even know if we have. Then cool. I'll have to write a few more test cases now. Like we're only currently checking the add instruction. Right. I'm not sure if how we've implemented the type checking is correct for every instruction. Could take a look here at all the instructions that we have. So alloca does not even use or have any arguments in that sense, so it doesn't matter. So it should be correct, I guess. Store doesn't return anything. I don't even know what type we give store though. What type does store have? What type does store have? It just has the type of the value that's stored. Okay, so that should be fine. I think what is not fine is load, right? Because I think the type that the instruction gets for load is yeah, the type is the type of the data that should be loaded, but for example, the register will be pointer type, right? Yeah, pointer type. That's it. Because we should only load from pointers, right? So that's where our current type checking here would fail, because this will be, for example, if we try to load a signed 32-bit integer, that will be i32, this type, as we expect, but then if we try to load from a register as a pointer type, so correct, but then this will return pointer to i32, and they are obviously not the same. Okay. Maybe we need an exception for load. For op, it's fairly easy. I mean, op is basically like just a copy or an immediate move, kind of. So just an assignment to either register or constant value. That should be fine. Sub is the same as add, should be fine as well. Compare has type boolean, but its operands do not, right? Yeah. No, the only the value should be a boolean, right? Other two can be anything. Okay. I don't even think that the type for compare is a boolean though. Even though it should return a boolean. I don't know, it's weird, I think. We'll try it. Let's see. So, if we now use a compare instruction here, or we just return compare, I think it's the syntax like this, where you compare 1 and 0, and then return. That doesn't even matter. See? Right. Okay, so it returns a type mismatch, where it says it expected a bool, the actual is 32. Yeah. Okay, that makes a lot more sense. That actually makes a lot more sense. So what do we need to do? I think we yeah, we need to also validate that separately. Okay. I think I'm done though for now. I'll note that we have to, where is it? Somewhere around here. Yeah, here. I note that we have to adjust this to actually use a different logic for comparing loads, comparison loads, I think. Yeah, that was it. And we'll do that in the next stream, I think, when we continue working on the verifier. So, say, extra case for comp and load instructions. So that will be our initial commit then. Like so. Cool. So you can check out the current state of where we are on GitHub. So we are currently working on this branch, the 11IR verifier. Yeah. I think I'll even open a pull request. Without much context for now. That's fine. So, cool. So you can even check out changes. Oop. Very nice. So, I think that will be it then, for today at least. I hope that at least like the second stream was a little better than the first one. I think the first one was really bad, like the quality wise. I don't know what happened there. I think I used the wrong encoding, so sorry about that. But yeah, if anybody's still watching, wish you a pleasant evening, and we'll see you hopefully next time. Somewhere, sometime, I don't know, this or next week sometime. I'll see. We'll see. Yeah. But thank you very much.